Today we are going to look at some examples of intermediate value theorem. Intermediate value theorem, or IVT, states that if a function is continuous on the closed interval AB, if a function is continuous on the closed interval AB and W is any number between f of A and f of B, these are the y values, so W is any y value in between f of A and f of B, then there is at least one number C in the interval AB for which f of C is equal to W. That means if you have a continuous function over the closed interval AB, then the function will take every single y value between f of A and f of B. Okay. Corollary is even more important, more powerful. A function has a zero in the interval if the value of endpoints changes sign. So if I have a function f of x where f of A and f of B have different signs, one is positive, one is negative, then I know my graph must cross the x-axis in between. I must have a zero or an x-intercept or a root or a solution if f of A and f of B have different sign, like in this case. F of A would be negative and f of B would be positive in this case. The y value is negative for point A. The y value is positive for point B. So y value switch the sign. If y value switch the sign, that means I do have an x-intercept in there. The graph must cross the x-axis. Here's an example. Verify the IVT applies to the indicated interval and find the value of C guaranteed by theorem. Do know here, f of x is a polynomial. Polynomials are always continuous. Always continuous. Polynomials are always continuous. So this function is continuous over the interval 0 of 3, thus IVT applies. IVT applies because this function is continuous over the interval 0, 3. Actually, it's continuous everywhere. So let's go ahead and check the sign of f of 0. So that would be 0 minus 0 plus 8. It's 8, which is greater than 0, positive number. And f of 3 would be 9 minus 18 plus 8, which is negative 1, which is less than 0. So f of x changes signs, or we can say this is, I'm going to call it point A and B. So this would be f of A and f of B have opposite signs. Opposite signs. There is a 0 in the interval 0 to 3. There is a 0, there is an x-intercept in that interval because f of 0 and f of 3 have opposite signs. And we can say f of 0 and f of 3 here, or we can label the 0 and 3 as A and B. Okay, so we are also required to find that point C, where f of C is 0. So let's go ahead and solve it. So plug f of x equal to 0. That gives me x squared minus 6x plus 8 equal to 0. Factors are x minus 2, x minus 4, x equals 4 and 2. Now, which of these is in the interval that we were talking about? X equals 2, or C would be the 2. The C value is 2. 2 lies between the interval 0 to 3. See another example. Prove that f of x is equal to x to the 5th power minus x squared plus 2x plus 3 takes on the value 2. So we're talking about the y value, that this function takes on the y value 2 at some point. First of all, f of x is continuous everywhere. F of x is continuous everywhere because it's a polynomial. It's a polynomial. Polynomials are always continuous. Okay, it's a polynomial. It's a polynomial, so f of x is continuous everywhere. Let's find 2 points where the y values will sandwich the 2 in between. So we want to find the function. We want to find the 2 y values where 2 is sandwiched in between those 2 values. They don't have to be right next to 2, but 2 has to be in between those 2 y values. So let's go ahead and check what is f of 0 equal to. F of 0 would be 3, and let's plug in f of 1 would be 1 minus 1 is 0. That would be also positive. So I'm going to start looking at the negative sides now, because if I plug a positive 1 or positive 2, I get a positive value. I'm going to go ahead and plug in the negative now. Negative 1 to the 5th power minus negative 1 to the second power, 2 times negative 1 plus 3. That all is going to leave me with a negative 1. So f of 0 and f of negative 1. So 2 lies between these. Up. I did not mean to clear the page. So we just said f of x is continuous because it's a polynomial. Okay, because it's a polynomial. F of x is continuous because it's a polynomial. F of 0 was 3. F of negative 1 was negative 1. So now f of 0, 2 lies in between the 3 and negative 1. So 2 lies somewhere in between 3 and negative 1. So we can say 2 lies between f of 0 and f of negative 1. Thus, using IVT, intermediate value theorem, function takes on the value 2. Because it's a continuous function, IVT says if you have a continuous function which is continuous over the closed interval 0 to negative 1, then your function will take every single y value in between the f of 0 and f of negative 1. Find an interval of length 1/4 in 2 to 3 containing a root of the equation. Okay, so we want to find an interval of length 1/4 in this closed interval that has a root for this polynomial. We do have other ways of solving this polynomial, but today we're only going to focus on the intermediate value theorem. We're focusing on using how we can use intermediate value theorem to estimate the root or a solution for a polynomial. So I'm going to start by f of 2 and f of 3. Now we also know that f of x is a polynomial, thus continuous over the interval 2 to 3, continuous from 2 to 3. Okay, f of 2 is going to be negative 9, 2 to the third power minus 8 times 2 minus 1, which is negative 9. And f of 3 is going to be 3 to the third power minus 8 to the 3 minus 1. F of 3 is positive 2. So 2 and 3, f of 2 and f of 3 have opposite signs. There is a 0 in between. F of 2 and f of 3 have opposite signs. There is a 0 in the interval 2 to 3. So what we're going to do now is we're going to cut that interval into half. And so we already know that f of 2 was negative, f of 3 was positive. So we're going to cut it into 2 intervals and look at the interval 2 to 2.5 and 2.5 to 3. Okay, let's go ahead and find out what is f of 2.5 is. So plug into a calculator, grab a calculator and plug 2.5 into 2.5 to the third power minus 8 times 2.5 minus 1. That's going to leave me with a negative number. 2.5 is going to leave me with a negative number. So with the 2 it was negative, 2.5 is negative, 2.5 is negative, 3 was positive. So I can tell that my 0 does not lie in the interval 2 to 2.5 because I didn't change the sign. So instead it lies between 2.5 to 3. Now let's split that interval 2.5. Let's bisect it into 2. So 2.5 plus 3 divided by 2, that's going to give me 2.75. So I am now going to look at 2.75 to 3 and 2.5 to 2.75. Now at 2.5, I do have a negative value. At 3, I have a positive. Let's check out if I plug 2.75 for the x. That is going to leave me with 2.75 to the third power minus 8 times 2.75 minus 1. And that's going to leave me with 2.75 will give me a negative number. I don't care what value it is. I just see that it's going to give me a negative value. So that means my 0 does not lie in this interval. That's going to be in this interval. We could be bisecting further and estimating the 0 to the nearest tenth of the value, but we don't need to do anything more because it did ask me to find the interval of length 1/4. So I'm going to say my solution here is interval is 2.7523. That's the interval, and the length is 1/4 or 0.25, and I do have a 0 in that interval. Next example, show that cos x equals x has a solution over the interval 0, 1. First of all, I'm going to write it in the equation form. Okay, so I'll clean up from the previous problem. Don't need this here. So I can say f of x here is cosine x minus x. And I'm trying to say that it does have a solution in the interval. Cosine x is always continuous, x is always continuous, so their difference will be always continuous. F of x is always continuous because of the individual functions are always continuous. So f of x is always continuous. Let's go ahead and check the sign of f of 0. Make sure your calculator is in the radian mode. Cosine of 0 minus 0. That's going to give me 1 minus 0, which is a positive number. And now I'm going to check the sign of f of 1. That would be cosine of 1 minus 1, and that's going to give me negative 0.45, which is a negative number. Using IVT, there is a solution for the equation f of x or y, doesn't really matter, whatever you want to call it. F of x equals cosine x minus x in the interval. Because the y values changes sign, f of 0 and f of 1 have opposite sign, so we can say there is a solution for this equation. We were not asked to find the solution, so I'm not going to bother to, but if you were to find the solution, you can continue to bisect the interval and check, just like we did in the previous example, what is your solution. So you'll have to do a lot of bisection, and eventually you'll be able to get to your 0. Another example we have here, so show that e to the power x plus natural log of x equals 0 has a solution. So in this example, I'm not even told, they didn't give me an interval, so I have to start with f of x is e to the power x plus natural log of x. F of x is always continuous in its domain. What's the domain for e to the power x? Well, domain for e to the power x is all real numbers. Domain of natural log of x is from 0 to infinity. 0 is not included, right? So think about graph of e to the power x. Domain is all real numbers. And graph of natural log x looks something like that. So natural log of x, e to the power x. So if we have a sum or difference of these two functions, the domain would be 0 to infinity. F of x is always continuous in its domain. It's always continuous from 0 to infinity. So that means when I'm picking my x values to test or check the y value sign, I'm only going to pick from 0 to infinity, and I'm not going to pick 0. Let me go ahead and pick f of 1. Because I cannot pick 0, I'm just going to pick some nice values. F of 1 would give me e to the first power plus natural log of 1. Natural log of 1 we know is 0. E to the first power is a positive value. E is about 2.7. So that's a positive value. Now I'm going to try f of 2. Let me go ahead and plug f of 2, e to the second power plus natural log of 2, and see what that gives me. E squared plus natural log of 2, and that is going to be 8.08. That is also positive. That's also positive. And let me pick, it looks like I'm getting more and more positive values. I'm going to pick something between 0 and 1 and see what happens. Something really, really small. Let's pick 0.1. 0.15 e to the power 0.15 plus natural log of 0.15. Okay, grab your calculator. E to the power 0.15 plus natural log of 0.15. And that's going to equal negative 0.735, negative 0.735, which is a negative value. And that's all I needed. So I needed to find two y values where f of x changes sign. So f of 1 and f of 0.15 have opposite signs. Therefore, using IVT, there is a 0 in the interval. It didn't ask us to find the 0, so I'm not going to do the work to find the 0. So there is a 0 in the interval from 0.15 to 0.15 to 1. There is a 0 for that equation. That's all for the examples of intermediate value theorem. So your goal is, intermediate value theorem says if you have a continuous function, then your function will take every single y value between f of a and f of b, where a and b are 2 points on the x-axis. And corollary says if f of a and f of b change the sign, then your graph is crossing the x-axis. You do have a 0 in that interval.